In this video, we're going to create a new work order, also known as a job, within OpenPoint Map. Then we're going to walk through the process of installing and retiring plant. Here's the scenario. We will be replacing two poles and the primary span of wire between them. Then we're going to extend service to a customer by adding a riser, a secondary underground wire, an underground transformer, and we'll add a service wire going out to the customer. Let's switch over to ArcGIS Pro now and OpenPoint Map and get started. So I have a system map, and I'm going to move over to the location on the map where the job construction will take place. The next step is to create a brand new job. So I'm going to go to the OpenPoint menu, and I'm going to find the Jobs options, and I'm going to click on Add Job. The first field on the Create Job window is called Type. This defines the type of work order and will indicate how it proceeds through the workflow process from the beginning all the way through the closing process. Below that is category. This list is customizable for each utility and defines how the work order is categorized. So some examples are electric maintenance, electric plant, fiber, water maintenance, water plant, etc. Let's select electric plant for this example. Below that is the job code or job number. So in this case, I'm going to just put in a value. This can also be auto-generated by the system based on a set of rules that define the codes and sequential numbers that are used based on the category that we previously selected. Below that is the description field. And so I'm just going to put in a description here. This could be anything that helps you describe the work order. And below that is another optional field called classification. This is another drop-down that lets you define whatever values that you want. So however you want to classify work orders can be done there. Below that is the CPR district. And so that's defining the property records district that this job is associated to by default. One particular work order can span across multiple districts, and you'll see that later in this demonstration. We're going to let this default to 01, which is indicating that it's in the city. Below that is the warehouse. And so you can choose from a list of various warehouses at the utility. And what this will do is it will become the default value used when issuing inventory for this particular work order. Below that is the start date, and so you can pick a date for that. It's optional, so you can leave that blank if you want. Status notes is also optional. I'll leave that blank. Prior CPR year is for a particular purpose, which we'll get into in a different video. And then the final option here is cold construction hours, or you can slide that over to hot construction hours. When this screen is completed, click the Create button, and then the work order record will be created. The work order we just created is now the active job. If I click on the Jobs button, I can see that it is selected down below, and you can tell it is the one we just created in the previous step. You also notice that this job number will appear in other windows within OpenPoint Map to indicate that it is the current selected job. So let's close that for now. And what we need to do now is to indicate what is going to be installed and what's going to be retired on this particular work order. So let's go ahead and select the first pole that's going to be involved. And so notice that when I selected it, it turned it to blue to tell us that it is the highlighted symbol on the map. So we're going to be making changes to this particular pole. So the next thing we're going to do is click on construction units. So what the construction units show is what happens to be installed in that particular location right now. So you can see here that we've got an 8-foot cross arm, and then below that we have a 30-foot class 5 pole. So let's go ahead and click on the pole, and then down below a pane will be displayed showing additional information. So we've got the P30-5, which is the assembly code, the description. Below that is the count, so how many are installed there. The CPR year indicates the year that the pole was installed. The station number, also known as the pole number, is a unique identifier for that particular pole and is often stamped directly on the pole. The CPR district indicates where this is installed in the system. And then we have the category and subcategory, which categorizes that particular pole as it is installed in this particular location. the unit code, the count, CPR year, and CPR district all work together to tie this pole's information directly into your property records. You can think of this as a representation of your property records in your system map. Now let's talk about assemblies. I'm going to switch over to OpenPoint Web for just a moment and display additional information about the Cross 8 assembly. We think of assemblies as the glue that ties materials and equipment as used by your operations staff in the system with the assets and accounting information that exists in your property records. This gives the operations team and the accounting team a way of speaking the same language. Operations staff generally become familiar with the codes and know what they mean in the field. Accounting staff use the assemblies to help spread costs based on standard labor hours and tie into specific account numbers in the continuing property records ledger. So in this particular example, let's go over some of the values that are associated to the Cross 8 assembly. First, we have the unit code itself, and this is generally a short descriptive value. Below that is the full description of the assembly. And then I'm going to switch over to materials here. So the materials indicate exactly what that particular assembly indicates when it comes to the physical equipment and materials that are installed or that are being retired. So in this case, we actually have two items that are associated to the Cross 8 assembly. We have the cross arm itself, so that's indicated here, and the unit code in this case is actually the code that represents the material in the inventory system. Below that, we have a cross arm bracket. Notice here that the count is 2. So when this assembly is on a work order and then you go to issue the materials out of inventory, OpenPoint is going to know to automatically do 2, since this is set up to do 2 brackets whenever a Cross 8 assembly is used. So let's go back to the Assembly tab and continue on from there. The next field is the CPR count. And so the CPR count generally can be 3 values. 1, meaning it has just a single count impact on the property records. 0 means that it won't impact the property records at all. And then 2 would be used for something like a double cross arm. So you don't have to remember to tell it 2 cross arms. You can just indicate that I've got a double cross arm. Probably you'd note that in the description, and then the system will automatically know that it means 2 in the property records. Below that is the category and subcategory. We talked about this previously on the construction units pane. This is actually the default value whenever this assembly is used, and then from there it can be changed if needed when you're on the map. Below that are the account numbers. So if this is going to be a capital work order, then the 364.2000 account will be used. If it's a maintenance work order, then the system will automatically use the 593.0100. Below that is the linear indicator, and so this is not linear. If it was linear, we'd have some additional options. Below that, we have the standard labor hours, so in this section here. So we've got installing cold hours, installation hot hours, removal cold hours, removal hot hours, transfer cold hours, and transfer hot hours. And so these hours are aggregated together on the work order with the other items that are being installed or removed from this particular work order. And so as those are compiled, then you get totals that can then be used for spreading labor costs to the particular work order based on a percentage. So that kind of covers the basic values of the assembly. Let's go back to the map. The next step is to install and retire assemblies. To do this, we're going to click on the Job Layout button right here, and then I'm going to start by removing, so I'll click the Remove button, the items that are currently on this particular pole. So the first thing I'm going to do is go to this cross arm, and then I'm going to check the Remove box there, and then click Remove, so that will remove it. I'm going to go back to the Remove, and then I'm going to select the pole now, and we'll remove that. So the next thing we're going to do is then to install their replacements. So I click the Install button, and I'm going to start typing in the word cross for the 8-foot cross arm. So notice that the grid below updated itself automatically as I was typing, and what it's doing is looking for the word cross anywhere in the unit code, category, subcategory, or unit description records that are in the system. And so that's one way to go and find an assembly to install is by typing in part of its name, or if If you happen to know the full code, you can put that in as well. It'll give you a single option and you can select it. Down below you can see what it did there as far as the details of the construction unit. So we've got a count of 1. It's got construction as the application type because this is going to be a capital work order. And then we've got a station number which came from the poll, the CPR district which came from the poll, and then the category and subcategory which came from the cross-arm assembly as we discussed previously. So now I'm going to install the 30-foot pole. So again, we know what the unit code is. So I'm just going to type that in. And that completes the pole, the first one of the poles. Now we're going to switch over to P101 here and basically do the same thing. So I'm going to do remove to remove what's there, but this time I'm going to use the select all feature. And notice that it automatically selected both of those when I hit the select all option. And so now I can just remove those in one step. And then we'll put in their replacements. So we'll do the cross 8 cross arm and the P30-5 pole. Now this time we also want to install a riser because we're going to be going from overhead to underground. So I'll get that selected. And now we can switch over to the wire. So we've got the wire that goes between these two poles and go back to remove. Get that off of there, and then we'll install the new one here. And I know this is going to be 1/0 ACSR, so I will go ahead and select that. So notice too that we've got some additional options here. So we had previously we had the count, the application, station number. This has a 2 station number, and that's optional if you want to fill that in or not. So I could type P101 here if I wanted to. The district like before, but now we have a length, a sag, an extra length, and a buffer field. So the length actually comes from the length of this particular wire. So it knew what that was and it filled that automatically. Sometimes that might need to be adjusted, so you can do that. There's also a sag factor that's involved. So since this is overhead wire, it will have a little bit of a sag. And so that came from the assembly. It knew that there was a 4% sag there, so it puts 104% there automatically, and that can be adjusted if needed. Extra length is if you have, like say in this case, an extra spool of wire hanging up on the pole for future expansion, you can put that there. And then buffer, this also came from the assembly, and it gives you a little bit of extra conductor when you're pulling from inventory. It'll give you a printout that says, instead of doing 99 feet, do 104, 99 plus 5, just so you have some extra to work with, and that's also configurable. We've completed installing and retiring where we had existing symbols on the map, but now we need to sketch out the new map symbols and then indicate what's remaining to be installed. I'm going to start off by adding a new secondary wire. So I'm going to go to the Create option here, and then I go through my list of features on the right until I find secondary underground. So I've found that. I'm going to click on that, and then I'm going to snap it to the center of this pole. And then I'm going to start drawing the line. I'm going to right click, and then there's an option here called distance. And so I know this is about 80 feet out, so I'm going to tell it to set the length for me automatically there. And then I'm going to place the wire. So now I'm going to click on attributes, and we'll just talk about a few things that were filled in here. So it automatically knows the circuit. It came from the previous wire, so that just flowed through it automatically. It has the station number from the previous pole. It doesn't know where it's going to, but I happen to know that where we're going to is going to be a transformer pad called pad 500, so I'm just going to fill that in. It pulled in the span from the length of the wire, and so in this case, a lot of times it's common to adjust this slightly, so I'm going to say it's actually 82 feet here. And then the phase came from the previous phase of the connecting wire that we just came from. So notice here that the district is null. And so there's actually 2 districts that you're seeing on the screen. The top is the city and the bottom is the town. And this wire happens to go in between those 2 districts. So I'm going to have to tell it what it is since it doesn't really know which one. And since we started in the city, we're going to go ahead and say that it belongs to the city. The next thing we're going to do is then to create the transformer. And so I'm going to go back to create, And again, looking through the list, and there's my underground transformer. So I'm going to click that symbol, and then I'm snapping it right to the end. And so notice that the label said pad 500 automatically, and if I look at attributes, that station number did get filled in automatically. It came from the wire since it could see that those things were connected. So it figured that it would automatically populate that. If it does do something incorrectly, you can easily just overwrite those values. Notice this time, however, that the district automatically populated with the town option because this is fully within the town boundary. The next thing we're going to do is then add the service wire. So back to create, and this time I'm going to find service underground. Again, we're going to snap to the transformer, and this time we're going to say the distance is 20 feet. So I'll put that on there, and then I will place that. And then finally, we will go ahead and do the meter. So I'm going to click on the meter symbol and then place that right at the end of the line. So that covers just the map portion of it. So now we need to actually put in the construction units that are being installed. So I'm going to go and start from the beginning here and select that first secondary wire and say install. And then I'll start entering in the assembly code there. So we're going to go ahead and pick this 350 triplex secondary wire here. So I've got that. I'm going to go ahead and leave all these default values, and then I'm going to move on to the transformer, and we'll go ahead and do install there. And we'll put in the transformer pad. That's going to go with that. Now notice that I didn't actually install the transformer itself. Some utilities will have different processes around transformers and meters both, and so those may sometimes be done in separate processes outside of a work order. So to keep this one simple, we're going to go ahead and assume that, and we're just going to install the transformer pad, and then I'll click on the service wire and do an install there, and then we'll type in the code for that, SBCURD. And then I'll select that, and again I'll leave all those default values. So now I just need to click on the save option right here, and that's going to save all my changes. And then the final step is to go back to the job screen, and then we want to say send to approved. So that's basically indicating that we have approved all the changes and it is ready to go. And depending on the utility and what process you use, you may be doing some of these things in advance of the actual construction, or you may do this part first like I just did and then send out staking sheets and a map showing what's going to be actually constructed, and then the construction would actually occur and you'd get the as-builts back in. At this point, then you can go back into this particular job and you can make any necessary changes. You can adjust the size of, or say the footage on a wire, for example, or maybe use a different item than what you intended to. So you just go back to the features and make those changes. But when you've made all your final changes, the last step is to do this send to constructed. So I'm going to go ahead and do that here. And what that does is it actually commits the changes that you made on the job to the plant record. So before that, we were just basically proposing changes. So once I say send to constructed, now it is actually physically indicated in the database that you have put those items there and removed whatever was removed. So that's kind of the last step in this process. Now we can switch over to OpenPoint Web and complete the rest of the job. So I'm going to click on website. This will take us directly into OpenPoint Web with this particular job loaded. So notice that the layout is already populated. So this contains all of the items we just installed or retired from the map. That just was synchronized right over. You can also see all the materials that will need to be installed. And you can see there's sections here for the transactions. So you'll be able to put in all of your labor costs, any contractor costs. When you issue out of inventory, then those material costs will also show up here as well. Once that's all completed, you can then allocate your costs, and that will spread the cost from the transactions to the various accounts. And then the final steps will be updating your general ledger and then also closing the job, which will then update the property records. That basically completes the workflow process, and in other videos we'll go into more detail about the transaction portion and the cost allocation portion as well, and that whole closing process that goes with it.